Hi everyone, I'm Trish Connor-Cato. Welcome to the Excel 2021 Visual Basic for Applications video course. This course is for beginning users looking to automate repetitive and recurring tasks in Microsoft Excel. VBA, as it's known, is Microsoft's programming language that is built into the Office applications. Our focus during this course is on Excel specifically. A key component of VBA is its language elements. We'll learn about this important topic by reviewing and using variables, their scope, and how to declare them. You'll also gain an understanding of VBA data types, intrinsic functions, and the with-end-with structure, and how it provides efficiency in your code. You'll learn to create message boxes and input boxes in this lesson, as well as gain an understanding of object variables. The next lesson will teach you how to control program flow through supported control of flow structures. This lesson begins with an overview of structures and Boolean expressions. You will then learn how to utilize conditional branching, and the lesson ends with learning how to use looping constructs. By the end of this course, you will be equipped with the basics to start writing your own VBA code, modify macros you've recorded, and have an understanding of how VBA lends itself to creating efficiency in your daily tasks. Our fourth lesson is about variables, data types, intrinsic functions, and object variables. We have several topics in this lesson. First, I'm going to say that these are some of the foundational VBA language elements. We've already used comments in VBA code. Those are a foundational VBA language element. And as you've seen, they happen automatically if you fill out the description box in the record macro dialog box. So there are other foundational VBA language elements, and we're going to drill down on them in this lesson, starting with gaining a thorough understanding of variables. Then we'll move on to VBA data types, intrinsic functions, the with-end-with structure. We saw an example of that when we recorded our first macro, and it put everything from the paragraph group on the home tab of the ribbon in Excel into a with-end-with structure. When we reviewed that code, I said that structure actually saves you typing and thereby makes your code more concise. You'll learn about the offset property and how to use it. Then we'll move on to using message boxes, which pop up on the screen and display messages to your users. We'll create and use input boxes. That gives an end user the ability to type in a single entry. So it could be a line of text, it could be number, it could be anything, but they get a single data entry on an input box. And then you'll learn about object variables. Now in this lesson, in addition to using our macro-enabled vehicles file, we're also going to access two other files, VIN numbers, which is an Excel file, and so is sales fiscal year. So make sure you have those files in your working directory. One of VBA's main purposes is to manipulate data. Variables store data in your computer's memory when procedures are executed, and the data may or may not end up on disk. Some data resides in objects, like worksheet ranges. Other data is stored in variables you create. Data that is stored in a variable usually changes while your procedure executes. Variables are often considered the most important VBA language element. Of course, there are rules and conventions to naming variables. So the variable name may be up to 255 characters. It can be alphanumeric. The first character must be a letter. cannot use spaces or any of the characters on the slide. Sounds a lot like procedure names. VBA is not case sensitive when it comes to variable names, but it is case preservative. So when you declare a variable, and you'll learn how that works shortly, and you name it, if you type its name, say in all lowercase, but then later on when you go to reference it, you type it in proper case or uppercase, it will automatically convert it to lowercase, the way it was when you declared it. That's case preservative. There is only one convention. Use proper case for each word within the name of the variable, just like we've been doing with our procedures. And then there's examples. Today's date, then num. There are two ways to declare variables: implicit and explicit. Implicit declaration method is one that you want to avoid. You simply use a variable without writing a declaration statement. This can lead to code errors. So let's say you just use a variable and you call it today. And then later on, when you go to reference it, you misspell today. It's going to think that you're declaring another variable. Explicit is the method we use, where you're going to write a declaration statement to officially declare the variable. Now, we mentioned earlier at the top of our module windows, we have a statement that says option explicit. That statement forces you to do explicit variable declarations. And we got that statement from an option in VBA settings, and it was already defaulted that way. I mentioned it briefly in our second lesson. When we go back over to Visual Basic Editor, I'll point out that setting that causes the option explicit statement to show at the top of the module. Now, just like procedures, variables have scope, and that's the bottom table. So when you declare a variable, if you use either dim or private keyword, they mean the same thing. You declare a variable at the top of the module, right underneath your option explicit statement, before your first procedure. And you use dim or private if you want the variable available to all procedures in a module. Public keyword is also declared at the top of the module. That's known as the declaration section under option explicit. You use public if you want the variable available to all procedures in all modules. And then you have a static keyword, and that makes sure that variables retain their value even when the procedure ends. And you declare it at the procedure level, and you'll learn about that as well. When you declare variables, you assign data types to them. So this slide is showing you all of the available data types in Visual Basic for applications. I'm not going to go over all of these. You have a byte, which the range of values is 0 to 255 for the byte data type. You have an integer, and you see the range of values for an integer. You have long. So those are some numeric data types that you have. You have several other numeric ones. You also have a fixed length string, variable length string. When you declare a variable, if you do not assign it a data type, it will assign it the variant data type. Look how many bytes are used for the variant data type. So you want to assign the appropriate data type when you're declaring a variable. That is a preferred method. And now we're ready to get hands-on. We're going to be using the VIN numbers Excel file, and I'm going to just switch over to the Visual Basic Editor. So I want to point out a couple of things. First, let's look in Project Explorer. I still have my vehicles file open, my macro-enabled vehicles file. So I'm going to collapse that project. And I also now have a project for VIN numbers. Again, if you had 10 Excel files open, you would have projects for each of them at this point. And so we want to focus on the VIN numbers project. And we just have sheet 1 in that project. Now, if I look up at the title bar, it's showing VIN numbers.xlsx, but it's still showing the mod first code from our vehicles file. So I'm going to just double click sheet 1 in VIN numbers, and then it shows that code window, even though we're not going to use that code window right now. The other thing I want to point out is, let's go to Tools, Options, and right on the editor page, when we went through this earlier in the course to change your font size on the editor format page, I pointed out this require variable declaration checkbox, and I said leave it checked. That's what's causing the option explicit statement to show at the top of any module, any code window, and it forces you to declare variables, explicitly declare them. So we can cancel out of there. So that's the setting that causes option explicit to show up at the top. Now what we're going to do, we're going to insert a module, create a sub-procedure, and declare 6 procedure level string variables. And you'll see how this works. So the first thing we're going to do, and we can do it if you right-click in Project Explorer, if you right-click on your VBA VIN numbers project, you can hover over Insert on the shortcut menu and choose Module. So just another way, instead of using the Insert menu, you can right-click and insert a module. So now you'll notice we have a Modules folder in Project Explorer, and it's called Module 1 right now. We are going to create a sub-procedure. So we're going to just type it in. So we're going to type sub, and we're going to name it ParseVIN. And VIN is all caps. And we're going to press enter twice. Gives us our open and closing paren, our end sub statement. And we're going to do a comment line here. So let's do our apostrophe. This procedure will parse the VIN number into the appropriate columns. Press enter twice. And now we are going to declare our variables. We're doing these declaration within the procedure. So it's a procedure level variable, which means it's only available in the procedure where it's being declared. And so I'm going to show you the inefficient way first, and then the efficient way of doing this. So I'm not going to have you do the inefficient way. I'm just going to show it to you. This is the inefficient way. I declared each string data type variable on its own line using the dim keyword, which is the same as using private. Now I'm going to show you how we really are going to do it. When they're all of the same data type, I can just type dim one time, separate the variable names by commas, have the data type at the end, and it can be in just one line. So this is what we're going to do. I'm going to go ahead and get rid of these subsequent lines. It's a lot easier this way. I'm going to get rid of as string for right now. And you're going to type dim VIN num, comma, year, make, model, color, country, classification, as, and when you press your space bar after typing as, you get the pop-up list. It's only going to show you what you're allowed to use in VBA here. We're going for a data type. So we're going to start typing string, and it shows up on the list, and I can stop typing at that point and just press my tab key to get it in there. So we have one line with all of our string data type variable declarations. Later on, you'll see how when I use multiple lines for declaring variables is because I have some that are of one data type, some that are of another. So you can't put them all combined in one line. And you'll see that later in the course. To finish our sub procedure, we need to take a moment to learn about some of the intrinsic functions that we're going to be using. Well, intrinsic functions are functions that are provided by the application. So they're Excel functions. And they perform like a function procedure. They return values. So we're going to be using a few string functions to manipulate the VIN text string in the VIN numbers files. So on this slide, we're going to be using the left, mid, and right functions. The left function extracts specified text from the left of a string, and it gives you the syntax there. So left, and then in parentheses, 2 arguments, the string expression, and a numeric expression. And a numeric expression specifies how many characters you want extracted from the left side of the string. Mid extracts specified text from the middle of a text string, and you've probably used these functions in Excel. They do the same thing. The mid function has 3 arguments, though: the string expression, where to start in the string, and then the number of characters to extract. And then the right function extracts specified text from the right of a string. It has the same arguments as the left function. In addition to intrinsic functions, let's talk about the VIN numbers we're using. So I mentioned early in the course, this is all dummy data. They're not authentic VIN numbers on any of the files that we're using. They do, however, contain 17 characters, and there's an example of a VIN number. And we'll need to know the characters of the VIN number in our intrinsic functions, and I'll guide you through that. So we're saying that the first character in the VIN represents the country. The second one is the make. 2 characters represent the model, and that would be the 3rd and 4th characters. The 11th is the year of manufacture. The 12th is the color, and the 17th is the classification. So the last one is the classification. In our make-believe VIN number world, that's what we're using. So now we're ready to build the rest of our sub procedure. When we're done, it's going to parse the VIN number into the appropriate columns. So we've said that the country is represented by the first character of the VIN. So in this particular VIN, the number 1 would end up being in cell F2. So that's what's going to happen when we complete our sub procedure. I'm going to just switch back over to Visual Basic Editor. I'm still sitting at the end of my variable declaration line. I'm going to press Enter twice, and then I'm going to press Tab. And I'm going to type range, and in parentheses and double quotes, A2 dot select, which you can pull from the list. Enter. And then just so you can see case preservative, when I declared the variables, I did a capital V and a capital N on VIN num. I'm going to type it in all lowercase now. Just VIN num equal. I'm not doing a space after VIN num either. I want to show you something. And then I'm going to say active cell dot value. So A2, where the VIN number is going to be the value of the variable named VIN num. Cell A2 is the VIN num variable. Press Enter. and a couple of things happen. You'll see case preservative because VIN_num is in the case that it was when we declared it, and it did the appropriate spacing around the equal sign. Now we're ready to continue. And we're going to type year equals. So we're getting ready to assign a value to the variable year. And we're going to use an intrinsic function for this. So I'm going to do mid, open parenthesis, and right underneath it, you see the argument, right? It's looking for what string are we using. So we're going to type in VIN_num, because now the VIN number is assigned to the VIN_num variable, comma, and the year is the 11th character of the VIN_num. So we're going to type 11, comma, 1. We only want one character extracted, which is the 11th character. Close your parenthesis and press enter. So I go in the order of how I declared the variables. So we assigned VIN_num, we assigned year. Now we're going to do make equals. And we need to use another mid function here. And it's going to be VIN_num again. And the make is the second character of the VIN number, and it's only one character. And press enter. Now, the other thing you can do is inline commenting, which is kind of helpful. Let's click at the end of the VIN_num equals active cell value line. Press spacebar, type an apostrophe, and assigns cell A2 as the VIN_num value. And then do your down arrow. Space, apostrophe. We'll type the year is the 11th character, which I'm abbreviating, of the VIN number. Go down and then do a comment for your make, which is the make is the second character of the VIN_num. And press enter. And now we're ready to get in our model. So model equals, and it's going to be another mid, but the model is actually the third and fourth characters of the VIN number. So we're going to do mid VIN_num, and then we're going to do 3. So start at the third character, comma, 2 to extract 2 characters. And then I'm going to go ahead and do my inline comment. And it's going to be the model is the third and fourth characters of the VIN_num. And press enter. Okay, so our next one is color equals. Color is also a mid, and we will get to do a left and a right, but color is a mid. It's in the middle of the VIN number string. So we're going to set up our mid again, VIN_num, and the color is the 12th character of the VIN. So 12 and then 1. And you can type that as your comment. And then we have country, and we're going to use the left function for this one. Country equals, and it's going to be left, and the left and right functions only have 2 arguments. So we're going to use the same string VIN_num, and the country is the first character, and that's what we want it to extract. Do your comment line. And last but not least, we're going to do our classification. And that's going to be right. We're using the right function for that one because the classification is the 17th character of the VIN, and that's the last character of the VIN. So we're going to use the right VIN num, and it's 1. We want to extract one character from the right of the VIN number, which is the last character, the 17th. And then we'll go ahead and do our comment line. We're not quite done, but let's go ahead and compile our project, and we're going to save. And so, we have to choose no on this so we can save it as macro enabled. So go ahead and do your no. In the Save As dialog box, we're going to keep the same file name, but we're going to change the type to Excel Macro Enabled Workbook. And we'll go ahead and choose Save. So far, we've started a sub-procedure, declared 6 procedure-level string variables, assigned values to the variables by using an active cell reference, but mostly by using intrinsic functions. And we still have to assign the values of the variables to the appropriate cells. Before we can do that, you need to learn a little bit more about the end width structure and the offset property. So we're going to compare these two code blocks on this slide. The first one is showing the word selection typed on every line, followed by a dot. And then you have your horizontal alignment, vertical alignment, and their settings, so on and so forth. In the second example, you have a end width structure, and it starts with selection. Once you do that, you don't have to type the word selection on every line. It actually makes your code more concise and easier to troubleshoot. So we're going to be using that structure that we briefly saw earlier. We're actually going to be setting it up when we go back over to Visual Basic Editor. The other thing we need to, in order to assign the value of the variables to the appropriate cells, we're going to need to use the offset property. It allows you to refer to a cell that is a specific number of rows and or columns away from another cell. So it's a property. It has the dot offset, and the row argument comes first, and then the columns argument. Both arguments are not required. If you use the rows argument, close the parenthesis after it. If you use the columns argument, use a comma as a placeholder for the rows argument first. When positive numbers are used in arguments, the property goes down rows and goes right across columns. When negative numbers are used in arguments, the property goes up rows and goes left across columns. Again, this is a reference for your future use. I have a couple of examples of using the offset property, and then we'll get back over to VBA and use our end width structure and the offset property. So if I'm on cell A1 and I do an offset of 1 row and 2 columns, it's going to put me in cell C2. It's going to go down 1 row and then go across to the right 2 columns. If I'm in C2 and I offset -1, -2, that will take me back to A1. And there's a few other examples here for your future reference. Let's get hands-on. So I'm going to press enter at the end of my classification line of code, press my tab key, and type with active cell. And then I'm going to press enter, and I'm going to tab again. Dot, and the menu comes up. If you type the letter O, offset is at the top. You can tab it in. Open parenthesis. We're not going to use the row offset, so we're going to type a comma and the number 1. Close your parenthesis. Dot value equals year. So we're saying go to, so the active cell, right? The active cell is cell A2, and that's been assigned to the VIN_num variable. But the active cell is cell A2. So when you offset by one column, it's going to cell B2, and it's going to populate cell B2 with the value of the year variable. That's how we do our assignment. So when we parse it, it puts everything in the appropriate cells. We have to put a lot more offset statements in here. And because they're all just column offsets, we will only be using that argument. So I'm going to do enter. I'm going to do dot offset again. And I like to put my offsets in order. So we're going to do comma 2 dot value. And then that's going to equal make. Enter. So there you have the rest of your offsets that you want to put in. And when you get them in, after you're done, you're going to do a shift tab so you're at the same width margin, and you're going to type end width. The last thing I'm going to do here is get rid of these blank lines after my end width statement, just to kind of clean it up, make it a little bit more concise. There's too many blank lines there. And then we're going to compile and go ahead and save. And now we'll switch over to Excel and test this procedure. So I'm going to do Alt F8 to get to my macros dialog box. We didn't automate this one. And I'm going to just double click ParseVIN. And you can see that it extracted the appropriate characters of the VIN into the appropriate columns. And we can go ahead and save and close this VIN numbers file. We're going to get ready to use message boxes and input boxes. But before we do so, some important information you need to know about them. Both are functions. The MSG box function has 3 arguments: a prompt, buttons, and title. Buttons and title are in square brackets because they're optional arguments. You can just get away with the prompt. And these display pop-up boxes on top of the spreadsheet. One other thing, VBA will allow you to use the function without enclosing the arguments in parentheses. A best practice here is to always enclose function arguments in parentheses to err on the side of caution and to provide consistency in your code. If you do not use the title argument, the title will default to the name of the application, in this case, Microsoft Excel. So the prompt argument displays the text that pops up in the message box. The buttons argument is a number that specifies which buttons and icons appear in the message box. If it's not used, the message box will just default to an OK button. And the title argument will populate the title bar for the message box. And again, if you don't use it, it will populate with the name of the application. The buttons and icons that show in the message box have values assigned to them, but most commonly the constants are used. So a constant is like a variable in that they're declared. However, while variable values can change during program execution, constant values do not change. Instead of doing a variable for like sales tax, you can do a constant for sales tax because it rarely changes. You also have Excel constants, which we saw earlier after we recorded our first macro. When we went over the width end width structure, we saw Excel, I think it was for horizontal alignment, it said XL center. So that is an XL constant. VBA constants are preceded by VB, and those are the constants that are used in message boxes. So VB OK only with a corresponding value of 0 will just display the OK button. If you don't use the button's argument, It is optional. It defaults to just an OK button. And then you have OK and cancel. You have abort, retry, ignore, yes, no, cancel. And then you get to, after retry, cancel, these are icons. These next four, critical, question, exclamation, and information, those are icons that can show in the message box. So exclamation point will show if you choose exclamation. The information icon will show if you choose information. And then at the bottom, you have default buttons. So default button 1, right? Whatever the first button is, will be defaulted, which means it will have a black border around it and you can press enter to make that button happen instead of clicking on it. So you can assign that functionality to different buttons in the message box. Well, actually only one of them can have it assigned. I have some examples on this slide. I'm not going to go over the whole thing, but if you did something like VB yes, no plus VB exclamation, you would get the yes and no buttons with the exclamation point icon. So that's a way of writing it out when you're doing it. You can have multiple lines for the prompt argument by using the VB new line constant. So it's the message box in parentheses and double quotes for the text. Do you want to continue? You're using the ampersand as the concatenating character here. You're doing a new line character, and on the next line, it will say, click yes to continue. It will have the yes, no button, the question mark, and the title of the message box will say step 1 of 3. So examples for future reference for you. So the input box function has 3 arguments, prompt, title, and default. Title and default are optional, and these are used to obtain a single piece of information from the user. It could be a value, a text string, or even a range address. Input boxes always display OK and cancel buttons. So you have the prompt argument, and that's the text that's displayed in the input box. You have the title argument, just like the message box. It will give a title to the input box. And then the default argument here, you can put in a default value and the user can overwrite it with their input if necessary. So I'm back in our vehicles macro enabled file. And the first thing we're going to do is get rid of column I. We only put that there so we could see the results of our function procedure. So I'm going to right click the column I heading and delete. And then go ahead and save your file. Now I'm going to switch over to the Visual Basic Editor. And I'll just point out in Project Explorer that we only have one file-based VBA project because we closed the other file. And what we're going to do is we're going to modify our event procedure that we put on the new vehicle sheet. So we're going to double click Sheet 3 New Vehicles in Project Explorer to bring up that code window. We want to give the user more control. Right now, we created a worksheet activate event that's using our calling procedure, get new inventory, which has 3 procedures bundled in it. So when we call get new inventory, it's calling 3 other procedures, so they'll run one right after the other as soon as we activate the worksheet. Now when a user activates the worksheet, we'd like a message box to pop up asking them if they'd like to run the get new inventory procedure. If they say yes, it will run it. If they say no, then it won't run. So we're going to modify this. First thing we're going to do, click at the end of your private sub line and press enter twice. And we're going to declare a procedure level variable here. We're going to dim response is the name of our variable as integer. So every button in the box has a corresponding value. So we're using the integer data type on that. And then after that, we're going to click underneath your declaration line and you actually press enter again so you get that blank line, and tab. We're going to leave get new inventory there because we're going to use it, but we're not going to use it quite yet. We're going to type response equals and then MSG box. Now at this point, we don't want to put the rest of our message box, our arguments and everything on this same line. So in order to not get an error, we have to tell the Visual Basic editor that we're going to continue this on the next line. It's called the line continuation character. So we're going to do a space and then an underscore and press enter. Now, if we didn't do that space and underscore and we pressed enter, that response line would turn red because it's expecting the arguments for the message box function. We're going to tab again, and now we're going to do our open parentheses for our message box and double quotes, and we're going to type our prompt argument. Do you want to run the get new inventory procedure? ? And then close the quote. We're going to do a comma because we have to separate arguments with a comma, but we want to drop it down to the next line. So we're going to do a space and an underscore and press enter. VB, yes, no. So we're using the VB constant, yes, no, saying we want the yes, no buttons in this message box. We're going to do a plus sign and do VB question. So we get the question mark icon in the message box, comma, and double quotes, run, get new inventory, ? Close your quotes, close the parenthesis. So that's going to be in the title bar. Run get new inventory ? Will be in the title bar of the message box. But wait, there's more. We're not quite done. Press enter again. We have to do a little bit of an if statement here. So we're going to type if response equals VB yes. So if the end user clicks the yes button, then now do your delete key to get that get new inventory on that same line. So if the user clicks yes, then it's going to run the get new inventory procedure. If they click no, it's going to do nothing. We're not telling it what to do if they click no, but we're only telling it what to do if they click yes. And we don't need an end if here because it's just one if then statement. Weird, but true. So let's go ahead and compile and then save. And let's switch to Excel and test this. So we're on the inventory tab. Click on your new vehicle sheet tab. Your message box should pop up. So it has a title bar that says run get new inventory. It has the question mark icon. It has the prompt, do you want to run the get new inventory procedure, and the yes no buttons. Let's choose yes. And it ran that procedure. Now click anywhere within your data, Control A and delete. Click in cell A1, go back to the inventory sheet, go back to new vehicles, and this time choose no, and nothing happens. Let's switch back to our inventory sheet tab, and then we're going to go back to the Visual Basic editor. So what we're going to be doing is we're going to be modifying the get new vehicles sub procedure, and we're going to be declaring two procedure level variables. We're going to set one of them to the path of the current workbook. We'll create an input box function to populate the input box with a default value that the user can accept or override. And so we need to make sure that the received vehicles file and this file are in the same directory. Actually, all of the files from the video description, I have all the Excel files in the same directory. I have all the text files in the same directory. So we're going to start by declaring our variables, but first we have to make it to the right procedure. So we're going to go to Mod New Vehicles in Project Explorer, and we want to modify the Get New Vehicles procedure. Let me just show you something. Scroll all the way to the bottom of that module and click in anywhere in your Get New Inventory procedure. If you look up to the right in the procedure list, it now says the name of the procedure that you're currently in. You can use that list to navigate from procedure to procedure. If you had 20 procedures in this module, you wouldn't want to be scrolling trying to find them. So I'm going to do the drop-down arrow in the procedures list, and I'm going to select Get New Vehicles. And it takes me right to that procedure. It's on the line underneath your sub-line. We're going to press Enter, and we're going to declare our two string variables here. So we're going to type dim, and they're both strings. So we're going to do file location, comma, file as string. And now we're going to modify the code. We are going to click in front of Workbook's open file name, press Enter a couple of times, and then up arrow a couple of times. So we're going to type file location equals this workbook dot path. So the file location is whatever directory this workbook is in. And we're going to press Enter. Now we're going to type file equals, and this is where we're going to put in our input box. So we're going to do input box, open paren, double quotes. So now we're ready for the prompt argument. What is the name of the new vehicles file? Question mark. Close the quotes, type a comma. We're going to do the line continuation character, so space and then underscore and then enter. So now what we're going to do is we're going to tab in and we're going to type in double quotes, new vehicles file name, question mark, close the quotes, comma, line continuation character, enter. So that is the title argument. And now we're going to give it a default file name. In double quotes, received vehicles .xlsx. You have to reference the extension. Close your quotes, close your parentheses there. And now we're going to go down to the next line, so we don't have to press enter there. We already had another blank line. And on this one, we're going to type file equals file location space ampersand. That's the concatenation character to combine all of this into one thing. And then in double quotes, we're going to type a backslash space, another ampersand, and type file. So we're combining the path and the file name separated by a backslash. And that's going to be the value of the file variable. So right now, the file variable is an input box. What is the name of the new vehicles file? It's pre-populated with received vehicles. And then if they change it, it will be whatever they change the file name to. Then we want file to equal the file location and the file. So the input box. Okay, so now what we're going to do is we have that workbooks open line, right? And we're going to modify it. it's going to be workbooks.open file name, which is there. After the colon, after the equal sign, you're going to type file. So now when it goes to open the workbook, it knows its location and the name of the file based on the input box entry. We're going to get rid of the continuation character there. And now the line underneath it is red, and we want to delete that line. And let's just update our comments for this one since we made some changes. So in front of open another file, I'm going to say prompts user for the name of a file, comma, and then I'll change this to opens the file. And the rest of it is fine. And actually, before prompts, we should put ask the user if they want to run the procedure. And then I'll press enter and put an apostrophe in front of prompt. So it's not, you don't want to be in a situation where you want to have to scroll over to see your comments. So I'm going to do, after opens the file, in front of select, I'm going to do another enter, put an apostrophe, just so it's not a long run-on thing. So we want more accurate comments, and you just want to try to get into habits, right? Good habits are good. So if you change your code, go back and update the comments to reflect your changes. And now you can go ahead and it's going to ask you to compile again because you made changes within the sub procedure. Save again, and we'll test it. So we're going to switch back over and test our modifications. So we're on the inventory sheet. Go ahead and click your new vehicle sheet tab. Say yes, you do want to run the procedure. And then you get your input box. So title bar, new vehicles file name. Prompt, what is the name of the new vehicles file? And the default argument, we populated it with receive vehicles. And as you can see, that can be overwritten if it's another file in the same directory. And again, input boxes always come with OK and cancel buttons. We're not going to overwrite the file. We're going to just click OK, and it runs our procedure. And of course, we're going to select everything, delete it, place ourselves in cell A1, and go back to the inventory sheet. Object variables are another way to make your code more concise because you can avoid typing lengthy object references. You use the same scope statements you use when declaring regular variables, so dim, private, public, etc. And they're declared with object types instead of data types. So I have the syntax here. You're using whatever scope keyword you need to use, the name of the variable as object type. So here are some examples. Public sheet as worksheet, dim range as range. When you assign values to object variables, the process differs from regular variables in that you have to use the set keyword. So set variable name to equal object name. Set sheet to equal worksheets year-to-date sales. Set range to equal active sheet range from A1 to F12. Once you assign an object to an object variable, the object can be referenced by its variable name. We're going to be setting object variables now. We're going to leave our vehicles file open and then go ahead and open the sales fiscal year file in your working directory. This workbook contains multiple tabs. Each tab represents a date. And if you look at my screen, you can see it goes from June 1st, 2016 through August 26, 16. And each tab has different sales information. So on 26th of August, we have 12 rows. I'm excluding the header row. We have 12 rows of sales information. If I go to the 25th of August, I have 18 rows of sales information. Go back to 26th of August. So what we're going to do is we're going to create a sub procedure, and we'll be declaring and using object variables. Column I on each sheet contains the selling price of each vehicle. We want to sum that column and place the result in the cell 2 rows below the last populated cell in the column. So on the 26th of August, we want the result of the sum to be in this cell. On the 25th of August, we want the result to be in this cell. So it's not always the same cell, because there's varying rows of sales data. So that's what we're going to do in this upcoming exercise. So let's go ahead and switch over to Visual Basic Editor. And for this particular project, because there's so many sheets, you can see that Microsoft Excel Objects folder is quite extensive. I'm going to just collapse that folder so I don't have to look at it right now. I have to look at all of those sheets. What we're going to do is we're going to right click on that sales fiscal year project, and we're going to choose Insert Module. And it will take us to what is now Module 1 in that file. We're going to create a sub procedure here. So we're going to name it sub add totals. Press enter twice. And let's go ahead and get our comments in. So I'm going to do my apostrophe, and I'm going to type, will sum the selling price in column I and place the result 2 rows below the last selling price in that column. And I'm going to actually cut it off below, enter, then I'll do another one. The last selling price in that column. Press enter a couple of times. Now we're going to do our object variable declarations. So we're going to dim last cell is the name of our object variable as a range. That's our object type. Enter. Dim total formula. That's what we're naming our object variable as, and we're going to do a string there. Press enter twice, and then you're going to tab. So we're going to use the set statement to assign a value to last cell. So set last cell equal range. In parentheses and double quote, we're going to do I2. Close the quotes, close the parentheses, dot. When you do the dot, the list will pop up and you're going to start typing end. And when you're going to select end, and then you're going to do an open parenthesis, and it will give you another list. And at the top of the list, it's a direction list, right? The top, it's hidden by this little pop-up here, but it's on Excel down. So that's an Excel constant, right? So we're saying the last cell, and actually I misspelled it, good catch. The last cell object variable is going to equal column I, right? All the way from cell I2 to the end of the column. So when it finds a blank, it's not going to select. So select all the numbers in column I is basically what we're saying, and make that the last cell object variable value. After Excel down, you have to do a closing paren. You're going to press enter, and you're going to type last cell dot select. and that will show on the list. So select that last populated cell in column I, enter, active cell dot offset, and we're going to do in parentheses 2. So we're just using a row offset here. So it's going to select the last populated cell in column I, and then it's going to go down 2 rows. We're not using a column offset, sorry, we're just using the row offset, right? So it's then going to go down 2 rows. And then we're going to type a dot and select. So select that cell 2 rows down from the last populated cell in column I. Enter. We don't have too much more. Now we're going to do total formula. And this one we're going to do a concatenated thing. So we're going to do equal here. And we're going to do in double quotes equal sum, and in open paren you're going to type I2 colon, close the double quotes, space, ampersand, last cell dot address. I'll explain it after we get all of this in. Open paren, false, comma, false, space, ampersand, space, close quote, closing paren, and another double quote after the closing paren. Enter, and we have just one more line that we have to get in here, and I'll review it. Active cell dot formula, which will be on your list, equals total formula. And then enter, so you have that space for your end sub statement. All right, so last cell object variable has been set to all the populated cells in column I, starting with I2, going down. And then it's going to select that last populated cell. And then it's going to do an offset of 2 rows. So it's going to go 2 rows beneath the last populated cell and select that cell. And then it gives the total formula calculation. So it's the sum of I2 through the last cell address. And after last cell address, you have false, false. That's saying it's not absolute. Neither row or column is not absolute. And so we just concatenated that together. And then we're saying the active cell formula equals the total formula result. Let's go ahead and compile and save. Make sure you save it as macro enabled, and you're going to keep the same file name. So that means you're going to click no on that message box. So far, when we've run our code, we've run it as a block of code. So the whole thing executes and we see the end result. We want to do this one differently. We would like to run this code line by line, and then that way you'll be able to see the effect of each line of code individually on your spreadsheet. In order to be able to do this, we're going to use a process called stepping into code, but we need to arrange our code window and our Excel workbook sales fiscal year side by side. So just to gain more space in my code, I'm going to decrease the width of the Project Explorer and Properties panes. There's a divider between them and the code window. And then I'm going to take my code window so it's not maximized anymore. And mine just popped into position, but you want to resize your code window so it's like on the right side of your screen. And I'm going to actually make it just a little bit wider, my resizing. And then you want to click on your sales fiscal year Excel window, make sure that is not maximized, and size it so it's on the left side of your screen. And in Excel, I'm on the 26th of August sheet tab, and I'm just in cell A2. And now we're ready to learn how to step into code. So it will execute it. Instead of executing everything as one block, it's going to execute it line by line, and you'll see the corresponding effect on your spreadsheet. This is a good technique when you're trying to troubleshoot code, but sometimes you just want to see how it works in the background, and that's another reason for stepping into your code. In your Excel window, go ahead and do Alt F8 to bring up the macro dialog box. And in the macro dialog box, you're going to make sure that your add total, just click on it once, add totals is selected. And on the right side, you're going to click the step into button. And when you do that, if you look at your code window, you'll see that it just selected and highlighted yellow the name of the sub-procedure, the first line. So there is a shortcut key once you do step into from the macro dialog box to continue to step into each line. In the editor window, you use the F8 key. So we're going to press F8 on the keyboard. And notice it skipped all the comments and it skipped the variable declarations. And now it's on the first line of our code. No change so far in Excel. It won't execute that line to set the last cell to equal the range of I2 through the last populated cell in column I. It's not going to do that step until we're on the next step. So press F8 again. And there's no visible change on Excel right now because it just set the value of that variable. So now we're on the last cell select line. And again, you're not going to see that happen until we're on the next line. So F8 again. And now in Excel, you finally see something happen. It selected the last populated cell in column I. And we're on the active cell offset by 2 rows line, and select that. Go ahead and F8. So now it did that previous line. It selected the cell that's 2 rows underneath the last populated cell in column I. Now you're on your total formula line, and you're going to do F8. So it calculated the formula, but we haven't told it where to display it yet. So that's the currently highlighted line, active cell.formula equals total formula. Press F8 again. And now you'll see the result of the sum of the selling price in cell I-15, 2 rows beneath the last populated selling price in column I. And it's on your in sub statement. And you can press F8 one more time, and it's done with the process. So you got to see line by line what it's doing when it's going through the code block. So I will say that we will be getting the sum of the selling price on every sheet, but we'll do that later in the course. And on every sheet, when we do it, it will be 2 rows beneath the last populated cell in column I. For right now, we can go ahead and save and close our sales fiscal year workbook. So in this lesson, we started by learning about variables, what they're used for, how to declare them, why you should declare them, and using an explicit declaration. You learned about the scope keywords, so dim, public, private, so on and so forth. And so then we moved into data types, because when you declare variables, you have to assign a data type. Well, you don't have to, but you should. Remember, if you don't assign a data type when you declare a variable, it will assign the variant data type that takes up a lot of space. We moved into intrinsic functions. We built a sub-procedure where we used them to parse the VIN. We used left, right, and mid functions in that section. We learned the benefit of conciseness by using the with structure along with the offset property to be able to assign the right part of the VIN to the appropriate cell. We moved into modifying an existing event procedure by adding a message box to it, asking the user if they wanted to run the procedure. And then we created an input box with a default file name that the end user could change if they want to run the procedure and then have it use a different file. And lastly, we learned about the difference between object variables and the regular variables. And we set up an object variable in a different file so that we could calculate the sum of the selling price column and put the result of the function 2 rows underneath the last populated selling price in that column. In lesson 5, we're going to be focused on controlling program execution. Now, you've seen some small examples of this. We've used a couple of if constructs already, so you'll learn more about them in this lesson. So we'll start by understanding control of flow structures. You'll learn about Boolean expressions. You'll learn about conditional branching and looping constructs. So we're going to be using our regular vehicles file. We'll also be accessing that sales fiscal year macro enabled file and 2 files from the text files folder. And that would be inventory append and model. So you want to make sure you have those files from the video description, inventory append and model, already on your computer. So to this point, except in the last exercise when we stepped into code, we've worked with code blocks, either created via macro recordings or writing sub and function procedures that progress line by line through the code. This is known as a sequential structure. There will be situations where a sequential structure is not what you need for your project. In VBA, you use what are known as control of flow structures in your code to make decisions such as which statements to skip, testing conditions to determine what the code should do next, as you saw in the if structures that we've used. We've used a couple of them so far, and to execute some statements multiple times. So you have your sequential control structure, and again, each line of code is executed from top to bottom. You have unconditional branching. A statement directs the flow of execution to another location in the program without condition. And you've seen an example of that. We have a calling procedure that calls 3 other procedures, which are, by the way, known as called procedures. And that is an example of unconditional branching, that get new inventory calling procedure. Conditional branching is when the code to be executed is based on the outcome of an expression that evaluates to true or false, so a Boolean expression. It's also known as a decision structure, and it is used to implement conditional branching. That would be your if constructs that we use, right? If the user clicks yes, then run the procedure. If they click no, well, it does nothing. And then we have a looping structure, and that's a block of code that is executed repeatedly as long as a certain condition exists. So, in that last exercise when we did the sum of the selling price, and I said we will be populating the other sheets with the selling price sum, and we'll be able to do that by using a looping structure. Within both the conditional branching and looping structures, there are what are called constructs that you use to carry out the job of the structure. So we have 2 conditional branching constructs that we're going to use, the if, then, and select case constructs. We've used if, then already, but there's different variations that you'll learn as we go. And then select case is very similar to one of the if, then variations, and we'll be using that as well. So some people think select case is easier to troubleshoot and read than this particular if-then variation, and I tend to agree with that. Then you have your looping constructs, the for to next and for each next loop. So for to next executes a series of statements a specified number of times. For each next is used on collections. They do the exact same thing, just a little bit differently, but you get the same end result. Then you have a do while loop and a do until loop. They're pretty much used interchangeably nowadays. So the do while loop does something if something else is true, and do until does something until something becomes true. Again, this is reference material just so you'll have some grounding before we start working on this. A little bit here about Boolean expressions. A Boolean expression is an expression that evaluates to true or false, and many expressions contain two expressions on either side of a comparison operator. If the expression evaluates to true, the condition is met and the structure passes control to the code to be executed. So there's an example there, sheets.count less than 3. If the count of sheets is less than 3, the expression is true. If the sheet count is greater than or equal to 3, the expression is false. Boolean expressions are of the integer data type. They're stored as 0 for false and -1 for true. I'm not going to go over all of the VBA comparison operators with you. I will say, though, whenever I take on a new coding language, I always need to know how not equal to is represented because it can vary. So in Visual Basic, not equal to is less than and greater than symbols together. And you can test for more than one condition by joining Boolean expressions with a logical operator. You can use parentheses around these joined expressions if you need to change the order of operations for the expression. So you have a table with your logical operators and descriptions, and or not and exclusive or. And then you have examples of joined expressions at the bottom. Year greater than 2017 and make equals Chevrolet. When you're using and, both conditions have to be true. Selling price less than or equal to 15,000 or list price greater than 15,000. When you're using the or logical operator, only one of the expressions has to be true in order for the entire statement to be true. So I mentioned there are variations of the if-then construct. There are actually 4 variations. So the first one is just if-then. If the condition evaluates to true, it would execute the code after the then statement. If the condition evaluates to false, it'll do nothing. And that's the one we used for our message box, right? So if they pressed yes in the message box, then it would continue and run the procedure. If they pressed no, it wouldn't do anything. And then we have if, then, end if. When we did that if, then construct, I see it doesn't need an end if statement. Typically, you would want to have the end if statement at the end of your if block. You then have if, then, else, end if. So after if, you give it a condition. If that evaluates to true, it will execute the code after the then statement. If the first condition evaluates to false, it will execute the code after the else statement. So we could have done, if they click the yes button in the message box, then run the procedure. Else, if they click the no button, we could have done that, but we didn't need to write it out that way. And then lastly, you have if, then, else if, end if. And it's used to test multiple conditions, and it can take an action on any that evaluate to true. The else statement, you can also add an else statement before end if, and it can be used if all the conditions evaluate to false. You can give it something else to do. So it could literally be if, then, else if, else, end if. And you'll see how that structure plays out. So we're going to use our conditional branching structures in the vehicles macro-enabled file. I'm back in the Visual Basic Editor, and I'm just going to drag this so I can see my Project Explorer and my Properties windows again. And we're going to double-click our event procedure. So we're going to go to Sheet 3, New Vehicles, double-click it so we can get back to our event procedure. And we're going to modify this. First, we're going to select everything from response down to the if line, and we're going to press tab to further indent it. Then we're going to click at the end of our variable declaration line, press enter twice and tab, and we're going to type if active sheet dot range, and then in parentheses double quotes A1 dot value equals, and then we're going to type 2 double quotes with no spaces in between. That represents an empty cell. So if cell A1 is empty is what we have. After the double quotes, we're going to type then, press enter and tab. And now we're going to delete until that response line, and I have to shift tab. So we want to get that indented like that. So if active sheet, if cell A1's value is empty, then response equals message box. Do you want to run so it'll give you the message box, and then all of that kind of stuff will happen, right? Only if cell A1 is empty is what we're doing there. So we just put an if-then statement. We already had an if-then statement. We need to have an end-if statement. Click after if response equal VBS, then get new inventory. Press enter, shift tab until you're at the margin for the original if statement there, and then type end if. Go ahead and compile and save your project. Let's switch over to Excel and test this. So, show you how we're going to do this test. We're going to go to the New Vehicle Sheet tab, and we're going to say no in the message box. And then type any number in cell A1. Press enter. Click back on cell A1, go back to Inventory, go back to New Vehicles, and it will not display the message box because cell A1 is not empty. We're going to delete the number in cell A1, and we can go back and test it again. We'll do Inventory and then back to New Vehicles, and we'll just say no again. So we further refined the code. If there's something in cell A1, it's not going to display the message box to let us run the procedure. Switch back to the Visual Basic Editor. So far, we've used the if-then construct, and then we've used the if-then end-if construct. Now we're going to go to Mod New Vehicles, and we want to navigate to the very bottom of the module, and we're going to create a function procedure, and we're going to use the if-then-else end-if construct in this one. So make sure you have a blank line under your end sub statement at the bottom of this module, and we're going to type function, and we're going to name it get MSRP. And so what this function is going to do, it's going to determine the markup of a vehicle based on whether it's a current year or previous year vehicle. We're going to give it 2 parameters in parentheses, and they're going to be dealer cost is the first one, comma, and the second one is VIN num. Close your parentheses. Press enter twice. And now you're going to use your tab key to indent, and we're going to type if, and then we're using the mid function, the year of the vehicle is the 11th character in the VIN number. So we're going to do VIN num 11, 1, close your paren, equals, and in double quotes, the small letter B, then, and enter. And then you're going to tab again. So if the 11th character of the VIN number is B, then get MSRP, the name of your function, equals dealer cost, asterisk for multiplication, 1.15 for 15%. And we're going to do a inline comment there. So I'm going to do my apostrophe and say vehicle is current model year. Enter. Shift tab, and we're going to type else and press enter, and then tab. This line, we're going to type get MSRP equals dealer cost times 1.1. And the inline comment is vehicle is previous model year. Enter. Shift tab, and we're going to type end if. So if the 11th character of the VIN number is a B, then it's going to calculate a 15% markup. If it's not a letter B, it's going to do what's after else. It will calculate a 10% markup. After your end if, press enter so you get the blank line before your end function statement. So we just created a function procedure using the if then else end if construct. Now we're going to go create another one. We'll compile after we create our second function procedure, because when you compile, remember, it's going to review all the procedures in any module. So we're going to do another function procedure, and then we'll compile and save. So we're going to, in the get new inventory sub procedure, which is right above our function procedure, we're going to declare two variables. So right underneath your subline, I'm going to press enter twice, and we're going to declare, we're going to do dim dealer cost as single. So that's a numeric data type. Enter dim VIN number as string. So we have our variables declared for this procedure. Click at the end of the add formatting line and press enter. And we're going to type range, and then in parentheses and double quotes, A2 dot select. So we want it to select cell A2. Enter. We're going to assign the value of cell A2 to the variable VIN number. So we're going to type VIN number equals active cell dot value. Enter. Now we want to assign the dealer cost value in cell G2 to the variable dealer cost. So we're going to type dealer cost, name of our variable, equal active cell dot offset, right? Because the active cell is A2. So we're going to do the open parentheses. We're not doing a row offset, so we're going to do the comma as a placeholder. And we need to go over 6 columns to get to cell G2. Close the paren dot value. So the value of what's in cell G2 will become the value of the dealer cost variable. Enter. So now we're going to call the get MSRP function that we created and put its result in cell H2. So that code is going to be active cell dot offset. And we're going to do a comma 7 in the parentheses. So that takes us to H2. Close your parentheses, dot value equals, and this is where we're calling our function procedure, get MSRP, and we're going to use the arguments dealer cost, comma, and we're using then number. So when we created the function procedure, we gave it two parameters, dealer cost and then num. Now we're passing it arguments, so we're using this then number variable as the then num argument is what we're doing there. And so we're going to go ahead and close the parentheses. So now we're ready to compile and save our project. So let's go ahead and test what we have done so far, and then we'll go back and create another function procedure. So I'm on new vehicles, switched over to Excel. I'm going to click in cell A1, and then I'm going to switch to inventory, back to new vehicles, let it run the procedure with the default file. And you'll notice that it did populate the dealer cost in column G, and then the MSRP, notice that column is not wide enough, right? And let's delete everything on this sheet. Put yourself back in cell A1 after you delete. And in the meantime, go ahead and click back on inventory and then switch back over to Visual Basic Editor. So the reason why the MSRP column, the result of our get MSRP function, is not wide enough is because add formatting, which contains the auto fit column width, happens before that cell gets populated. So we need to fix that. And what we're going to do is I'm going to just cut that add formatting line. And I'm going to click at the end of the active cell dot offset line, press enter, and paste add formatting there. And then, of course, because of my OCD, I'm going to have to go back and get rid of the extra space in front of add formatting now. So that will fix the width of the MSRP column. But now we're going to do our other function before we come back. And so we're going to create a function procedure that makes it extract the actual year and put it in the year column. So we're going to go to the bottom of this module underneath our get MSRP function procedure. Press enter twice after the end function statement. And this one, we're going to type function get year. And it has one parameter that we're going to give it. And that's going to be then num. Enter, enter. Before we tab, we're going to declare a local variable in here. So we're going to do dim year marker as string. Then we're going to enter twice and tab. So we're going to use the if then else end if construct again, and we're going to use it based on the year marker as the 11th character of the then, right? And that's going to be if mid and then num, comma, 11, comma, 1, close your paren, equals. So if the year marker equals A, and we're going to put the lowercase a in double quotes, then enter tab. Get year equals, and we're going to put in 2018. So the letter A in the VIN represents 2018. Press enter, shift tab, else enter, tab, get year equals 2019. Enter, shift tab, end if. Make sure you have your line between end if and end function. So, if the 11th character of the VIN number equals A, then the year is 2018, or else it's 2019. And now what we have to do in the get new inventory procedure is we have to add the line of code that will call the get year function and place its result in cell B2. So what I'm going to do is I'm going to click in, let's see, we'll just do it like this. Click at the end of that dealer cost equals active cell offset line and get new inventory procedure. Press enter. And we're going to type active cell dot offset. And then we're going to do a comma 1 because we want to go to cell B2. Dot value equals get year. And we're giving it VIN number as an argument. And then because of my spacing, I'm going to press enter at the end of that line because I didn't space everything, and then get rid of the blank line. Go ahead and compile and save, and then we'll test. We'll test our change that we made. So we moved add formatting, and we'll test this get year function as well. So go ahead and run your test. You know how to get everything going. And when you're done, you should see that the MSRP column H has an adequate width, and the year is now in column B. We are, of course, going to select everything, delete it, click in cell A1, and go back to our inventory sheet before switching back over to the Visual Basic editor. So now we're going to use the if-then, else-if, end-if construct. This is allowing you to test for multiple conditions. I believe you can test for up to 7 conditions. You'll learn another construct shortly where you're unlimited to how many conditions you can test. So it's a very flexible construct. We're going to use it to evaluate the VIN character representing the classification of the vehicle. And then we'll update our get new inventory procedure to call this function that we're going to create and place its result in the appropriate cell. So under my get year procedure, function procedure, I'm going to go ahead and press enter after end function twice, and we're going to create another function procedure. And this one is going to be named get classification. And we're going to give it VIN num as a parameter. Press enter twice. We're going to declare this local, or also known as procedure level variable, dim class marker as string. Enter, enter. And then we're going to tab. And so the classification is the 17th character of the VIN, the last character of the VIN. So we're going to use a write function in this if construct. And then we have to tell it what class marker is. So the class marker equals write, and then in parentheses, VIN num 1. So the 17th character of the VIN number is what we're assigning to the variable class marker. Now press enter twice. and we can tab. Now we're ready to do our if construct. So if class marker equals 1, then enter tab, get classification, and you might want to copy get classification because you're going to have to type it several times here. Get classification equals, and in quotes you're going to type car. Enter shift tab. Else if, and else if is one word with initial capital letters in Visual Basic for applications. Else if class marker equals 2, then enter tab. You can paste in your get classification equals, and in double quotes, truck. Enter shift tab. We're going to do another else if. And it's going to be class marker equals 3, then your get classification is going to equal, in double quotes, van/minivan. Enter shift tab. Do another else if for class marker 4, and that would be an SUV. And you can see on my screen what that should look like. After your SUV line, you're going to press enter shift tab and end if. So now we're going to do another modification in our get new inventory procedure. So, we've been going in here and putting in our active cell offsets. We're going to create a with end with structure in here to make it more concise, because we're going to have several different offsets to put in. So click at the end of that dealer costs equal active cell dot offset value line, press enter, and you're going to do a tab, and you're going to type with active cell, and then you're going to double click active cell on the next line and delete it. Do the same on the following line and delete it. And then select your with line first. And we want to tab over a little bit more. And then we're going to select both of those offset lines and tab 3 times. So the whole with end with thing will be indented. Click at the end of your offset 7 value line. Press enter twice. Shift tab and type end with. So now this is where we're going to go in and make a reference, and we're doing them in order of the offset numbers, and we need to make a reference so it knows where to put the classification of the vehicle. So we're going to go in front of offset comma 7 and press enter, and then go up. So dot offset, and it's going to be a comma 4. So we're putting them in order of the numbers. It'll be easier if you have to troubleshoot it. And you're going to go ahead and get your dot value, and we're going to do equal get classification. So we're calling that function procedure, and we're going to give it VIN number as an argument. And I should have done my spacing right, so I don't have to put enter again. Okay, so we have our offsets in order. We don't need that blank line above end with. Sorry about that. So I'm going to just get rid of that blank line. And as we have to call other function procedures that we're going to create, we'll put them in that with end with structure so it's more concise. Let's go ahead and compile and save, and I'll have you go to Excel on your own and test this out. And when you're done with your tests, your spreadsheet should look like mine. We have the year in B2, the classification in E2, and the MSRP in H2. And notice it's not filling all the way down. It's only looking at the first VIN number, but we will get into how to fill the rest of the sheet down a little bit later. So I mentioned that the if then, else if, end if construct is valuable for testing multiple conditions, but it's limited in how many conditions it can test. An alternative to that is a different construct, also another conditional branching one, known as select case. It's the select case in select statement. So I have the syntax on the screen here. Again, this is for your future reference. I'm going to walk you through this. So we're going to switch and we're going to use the select case in select construct now. So we're going to, as usual, select everything on the new vehicle sheet, delete it, place yourself in A1 and go back to inventory and then switch back over to your Visual Basic editor. And we are going to use the select case in select construct in two different functions. The first will return the color of the vehicle, and the second will return the make of the vehicle. And you will have an opportunity to insert code from a text file during this exercise. So those text files that are in the video description, it's so you don't have to type really long blocks of code. I'm just going to navigate to the end of the module, press enter, and we're going to create a new function, and we're going to name it get color, and it's going to have a parameter of VIN num. We're going to declare a procedure level variable with a string data type, and the variable name is color marker. Now we're going to set the value of color marker by using the mid function to extract the 12th character of the VIN. So we're using mid VIN num, and we said it's the 12th character, so 12, 1. Mid function, remember, has 3 arguments, the character that you want to start with and how many characters to select. So we want the 12th character and only that 1 character. And now we're going to press enter twice, and we're going to tab, and we're going to type our select case statement in here. So it's select case, and then we're going to use color marker here. So select case, color marker, enter tab, case 0, enter tab, get color equals, and in double quotes, black. Enter shift tab once. Now you're going to do case 1, enter tab, get color equals white. Enter shift tab. So now I'm going to challenge you and have you fill out the rest of the select case information based on the information on this slide on your own. You can pause the video while you're doing it, and when you resume, I will be on my Visual Basic Editor screen so you can see my work. So when you're done, your function get color should look like mine, and the only thing we're missing is the end select statement. So I'm at the end of my unknown. I'm going to enter, and I'm going to shift tab twice, type end select, and enter. Any select case has to have an end select. And then I have my end function at the bottom. And now we'll go up and modify our get new inventory procedure. So for this one, we want the color to be in, it's going to be offset 5. So I believe that's column F. Well, actually cell F2. So we're going to keep them in order. Click at the end of your offset, comma 4 line, enter, and do it dot offset, comma 5, dot value equals get color, and we're using VIN number as the argument there. Go ahead and compile and save. And we'll test it after we do another function procedure. So now you're going to have an opportunity to create another function totally on your own. The information you need for it is on this slide. So you can pause the video while you're working on this, and when you're done, I will show you my code. And now you can see my getMake function, so you can compare it to your own. And when you're done doing that, we have to go back to get new inventory procedure. And we're going to do, so let's see. The make goes in column B, so it's a comma 2 offset. So set up that offset line for the make. And so that's the line you should have typed in there because we're doing them in order. And just in case you need to see it again, I'll go back down to my get make, and you can pause the video if you need some time to look at it. So now for the model of the vehicle, we're going to use a text file so we don't have to type this function. Make sure you're at the end of the module, and we're going to go up to the insert menu and choose file. Now I'm already in my text files folder from the video description, and we're going to double click get model. So if you scroll down, you can take a moment to review the function, space it appropriately, indent it appropriately. So just to review it for a moment, the model is in the 3rd and 4th characters of the VIN. And so if the model marker is 16, then the model is Catera. If it's 17, it's Seville, so on and so forth. So you can see, for me, select, case, in select constructs are a lot easier to review than if, then, else if, end if construct. Plus, you can do more tests in the select case one. So now the model goes into cell C2. So let's go back to get new inventory and modify our within with block. So I'm going to click at the end of the get make line in the offset group. And we're going to do an offset comma 3 for this one. And that line should look like that. I think I may have misspoken. We're putting it in cell D2. So that's the offset 3. So offset 1 is B, 2 is C, and 3 is D. So after you compile and save, switch over to Excel and test your procedure. And your results should look like mine. And once again, we're going to delete the data on this sheet, do our normal process here, and go back to inventory. And you can switch back over to the editor. We're going to address the other VIN numbers on the sheet by using a looping construct. And they're used to execute a block of code repeatedly. There are 2 types of looping constructs, do loops and for loops. And we'll be focusing on the do loops for right now. There are 2 variations of the do loop construct, the do while loop and the do until loop. The do while loop, that statement will run as long as a condition is true. The do until loop will run when a condition becomes true. Each of these constructs has two syntaxes, and each of them, do while and do until, test a conditional value, but the differences between the two control how they handle the tested condition. We're looking at the two different syntaxes for the do while loop. So do while the condition is true, it will run that statement block as long as that condition is true. Once that condition is false, it will come out of the loop and stop. Now, another way to write it is, in this one, it will run the statement block at least once. In the first one, it will execute the statement block 0 or more times, depending on if the condition is true, and stop when the condition is false. In this one, it's going to do the statement block and then loop while the condition is true. So it will execute it at least once. Similarly, the do until loop has two syntaxes, the first of which will execute the statement block 0 or more times, and the second will execute the statement at least once. So back in the Visual Basic editor, we're going to edit the get new inventory sub procedure by adding a do while loop to it. It's going to be 4 lines of code that we're going to type. So the first thing we're going to do in the procedure is we want to click at the end of the VIN number line. So I'll highlight it on my screen and press enter. And we are going to type do while VIN number. We're going to do the not equal symbol, so less than, greater than, and then a set of double quotes, no space in between. So we want the loop to run as long as the VIN number is not empty. So it's not equal to empty. We want the loop to run as long as there is a VIN number in the cell. Now we're going to click at the end of our last offset line. And again, I can highlight it on my screen. So right above end width. And we're going to press enter. And we're going to do dot offset, and in parentheses, the number 1. So we're offsetting by 1 row. And then we're going to type dot and select. So it's going to do all of the code within the loop as long as the VIN number in a cell is not empty. After it does the loop, it's going to move down 1 row, and if there's a VIN number in that cell, it's going to run the loop again. But first, we're going to press enter, and we're going to type, and we can shift tab that, well, we'll leave it indented. We're going to type VIN number equals active cell dot value. So when it moves down to the next row and there's a VIN number there, it's going to assign that to the variable named VIN number. You can click in front of add formatting, press enter, and then up arrow, and you're going to type the word loop. So it's going to run the loop as long as there's a VIN number in the cell. When there's no more VIN numbers, it's going to stop running the loop, and then it'll do the formatting. Let's go ahead and compile and save and switch to Excel and test the procedure. 4 short lines of code, and it populated the information for all of the VIN numbers on the sheet. Before we delete the data on this sheet, just want to point out that when we run this procedure, it brings in 10 rows of data, excluding the heading row. So we're going to go ahead and select and delete the data on this sheet. Click in cell A1 and then switch to inventory. Now on the inventory sheet, I'm going to do Control End, and it lets me know that we have a total of 105 rows of data, including the heading row. So the reason why I'm pointing this out, and I'm going to just do Control Home to get back to the top for right now. I'm pointing this out because in the next exercise, we're going to perform a few more tasks on this file. And specifically, we're going to use a text file that's going to insert code that will append the data on the new vehicle sheet tab without the headings to the data on the inventory sheet tab. Then we're going to write a sub procedure that's going to delete the data on the new vehicle sheet tab for us. And then we'll add the line of code to call the procedure that deletes the data. So we have 3 objectives here. Let's switch back over to the editor and get started. Let's navigate to the end of Mod New Vehicles. And we're going to press Enter. And we're going to go to the Insert menu and choose File. The text file that we want is Inventory Append. In this sub procedure, we're declaring last cell as a range, so an object variable, and a regular variable response as an integer. Response is going to equal a message box that has a prompt of append the new inventory now. It's going to have a yes, no button, and the title bar is going to say append inventory. If the response equals VB yes, so if the yes button is clicked, then it's going to set last cell to equal the range from cell H2 all the way down to the last populated cell in column H. And then it's going to set the range to equal A2 through the last populated cell in column H. And it's going to select that range. It's going to cut that selection. It's going to go to the inventory sheet. It's going to start in cell A1, go all the way down to the last populated cell in column A, and offset by 1 row and select that blank cell. And then it's going to paste the data from the other sheet, go back up and select cell A1, and then save the workbook. So that's what's going to happen here with this sub procedure. Now we're going to create a sub procedure at the end of this module. And this is going to be the one that's going to select and clear everything on the new vehicle sheet. So we're going to do sub clear sheet. Your usual enter a couple of times and indent. And we're going to do worksheets. And then in parentheses and double quotes, new vehicles dot select cells dot select selection dot clear, and then range A1 dot select. So it's going to go to that worksheet. So after it runs this one, the inventory append, it's in cell A1 on the inventory sheet. So clear sheet has it go to the new vehicle sheet, select all the cells, delete everything, and then click in cell A1. Now we're going to call the clear sheet procedure from within the inventory append procedure. In inventory append, we're going to click at the end of range A1 select, press enter, and this is where we're going to just type clear sheet. We want it to clear the sheet before it saves the workbook. And lastly, to be more efficient, we're going to go to our get new inventory procedure. And we're going to call inventory append from within here. And we're going to just do the call after our add formatting line. Inventory append. And now you're ready to compile and save. And we can go ahead and test this out. So we're going to go ahead and run our procedure. So now we get our message box, append inventory, append the new inventory now with our yes and no buttons. We're going to say yes. I've been getting this weird pop-up whenever I save. Sorry about that. But now notice new vehicles sheet, and I clicked because I got the pop-up. Your new vehicle sheet should be clear and it should be in cell A1. And if you go back to inventory and you do control end, you now have 115 rows of data. And we can go control home. And we can go ahead and save and close this vehicles file. Our last topic in this lesson are for loops. So another type of looping construct, and there are two variations, of course, the for to next loop and the for each next loop. The for to next loop, that statement will execute a series of statements a specified number of times. The for each next loop is used on collections, and it loops through each object in the collection. We're going to be using both of these constructs in this last topic. And we'll be doing this on the sales fiscal year macro-enabled file. When we worked in this file earlier, we created an add total sub-procedure, which added the total of the selling price on this particular worksheet, and it placed the result 2 rows down from the last populated selling price in column I. Now we're going to use a for to next loop to repeat that process on the other sheets in this workbook, including the 26th of August sheet tab. So let's go ahead and switch over to the editor. And there's our add total procedure. Right underneath it, under the end sub statement, press enter, and we're going to create another very short sub procedure, and we're going to name it all totals. And we're going to declare an integer variable, so dim I, I'm just using the letter I as the variable name, as integer. Press enter a couple of times and then tab. So this is how you type a for to next loop. And once we get it typed in, I'll go over it. So we're going to type for I equals sign 1 to the number 1 to worksheets dot count, enter tab, worksheets, and in parentheses I, dot select, enter, add totals, enter, shift tab, next I, enter. So now we're ready to compile, save, and switch over to Excel. So I just want to give you fair warning. When we run this procedure, we are going to get an error message. We'll talk about it when it happens. Because this is not an event procedure, we're going to do Alt F8 to open the macro dialog box. And we want the all totals procedure. So select that one and run it. And you're ultimately going to end back up in the editor with an error message. So we're encountering runtime error 1004, application defined or object defined error. If we click on debug, go ahead and click on debug, it takes us to a line in the add totals procedure. And we're calling that add totals procedure from all totals. So when we get to that active cell offset 2 dot select line is when the error happened. So this is when it set the last cell to be I2 all the way down to the last populated cell in column I. And then after it selects that last cell, it does the 2-row offset and it drops 2 rows below. And that caused the error. Now I'm going to show you how to clear this in a moment and how to resolve it. But first, I want us to switch over to Excel and I want to show you what caused the error. So what's causing this error is, if we look down at our sheet tabs, we're on the 4th of July sheet tab. There were no sales in the 4th of July. So when it went to column I and it went all the way down to the bottom, there's no place for it to do that offset. There are no more rows. So that's what caused the error. Let's switch back over to our editor and fix this. So the first thing you want to do when you get an error is you want to reset it so it clears everything, every variable value out of your memory. So we're going to use the reset button, which looks like a stop button on the toolbar. The yellow goes away. And what we need to do is we need to add 4 short lines to the add totals procedure. Let's select all of the lines from set down to active cell formula and indent, and then click at the end of your dim total formula as string line. Press your down arrow key and press enter and then tab just one time. So we're going to do an if then else end if block here. We're going to type if range and your parentheses double quote I2 dot value is not equal to 0, then, so if there's any number in cell I2 that is not equal to 0, then do all of this code. After the end of the active cell formula equal total formula line, we're going to press enter and shift tab. And we're going to type else and enter and tab. Range A3 dot value equals, and in double quote, no sales. enter, shift tab, and end if. So if there are any values in cell I2 that are not equal to 0, then run the procedure. If there are, we're going to put in cell A3, no sales. Let's go ahead and compile and save and switch to Excel. And I honestly didn't mean to say switch to Excel. We're going to test this fix after the next exercise. Now we're going to create the for each next loop, which works on collections. So this is what we need to do. We also want to name that subprocedure all totals. You can't have two subprocedures with the same name in the same module. So what we need to do is select our entire sub all totals for right now. And when we added buttons to our toolbar, one of the buttons that we added was comment block. So we're going to click on comment block. So it turned that whole subprocedure into comments, which means it's not really code at this time, according to VBA. So we can create another subprocedure in this module with the same name. Right underneath the commented out code, we're going to go ahead and create this other subprocedure named all totals. And this one, like I said, we're going to use the for each next loop in this one. So enter twice. And this one, we're going to dim sheet as worksheet. So we're doing an object variable pretty much there. The sheet is a worksheet. Enter twice and tab. All right. For each sheet in worksheets, enter tab, sheet.select, enter, add totals, enter, shift tab, next sheet. That's it. That's the for each next loop. It works on collections. So we dimmed sheet, the variable sheet, as a worksheet. For each sheet in the worksheets collection, select the sheet, run the add totals procedure, the one that we modified because we got that runtime error, and then go to the next sheet until there are no more sheets. This is going to do the same exact thing as the for to next loop, but it's just treating every sheet as a object in the worksheets collection. And since we modified add totals, we'll see that it works now and we should not get a runtime error. Let's go ahead and compile and save. And now we're ready to switch to Excel. In Excel, we're going to do Control Home on that 4th of July sheet. And then I'm going to right click on my tab scrolling arrows in the lower left corner, right above my status bar, to the left of my sheet tabs. I'm going to right click, scroll up, and double click 26th August sheet. Easy way to navigate, by the way, if you have a workbook with a lot of sheets. So we're going to try this again. We're going to do Alt F8. And it's the all totals procedure, the new one. And we're going to run it. And we don't get an error message because we told it what to do if it encounters a sheet that doesn't have any selling prices. So let's right click on our sheet tab scrolling arrows again and make our way up to the 4th of July sheet. Double click it. and you can see that it put no sales in cell A3. We're going to go ahead and save this file and leave it open for the next lesson. In Lesson 5, Controlling Program Execution, by way of recap, we started by getting an understanding of the different types of control of flow structures that are utilized in Visual Basic for applications. You also learned about Boolean expressions, and we started with conditional branching by using the variations of the if construct and then the select case construct. We moved on to looping constructs. We used a do-while loop, and then we used both variations of the for loops. I'd like to thank everyone for watching this Excel 2021 Visual Basic for Applications video course.